Okie dokie. Full screen. Here we are. We are in section 2, chapter 10. And so today, this lecture is very similar to permutation. We're switching to combinations. And in combination, order is not important. And so permutation is all about the order in which you arrange things. Combination, we do not care about order anymore. So that's our big difference. And really, it's so important for you to keep that straight, especially the word problems and thinking, tomorrow when I see you in class, we'll have a homework that we'll do in class. It'll just be combination problems. But the first quiz we take, you're going to have to choose between, hey, is this a permutation problem or a combination? So I'm going to try to start working with you on that. And again, if you read something in a problem where you realize the order in which things are being placed or done is important, then you're dealing with a permutation. We are also going to do Pascal's triangle today, which is really an interesting pattern that comes about and that ties in with combinations. And then the binomial theorem is fantastic and probably needs a full day, so I'm going to put this off probably till after break, but it's here anyways. So again, you feel free. I'm not checking your note sheet if you want to hold off on the writing like that binomial theorem. Man, I don't know if I'd write all that notation down. But definitely combination, again, it is, selection of R objects in a group of N objects where order is not important. Here is the formula for NCR. So again, we will use our calculator. I don't know if you noticed above the NPR button in your calculator, there's the NCR. And this is for, taking objects where order does not matter. So let's go ahead and do our first example. So you are picking 7 books from a stack of 32 books. If the order of the books you choose is not important, so that should trigger you to say, hey, this is not a permutation problem, this is a combination problem. How many different 7-book groups are possible? So here it is, 32C7. You're welcome to use the formula, but I'm hoping you will just punch this into your calculator. I'm very okay with it. So 32 minus 7 is 25. And then you're kind of done. That would have been permutation problem, but then you multiply by the number of choices, and which is in the denominator. So it actually makes, you should always get a smaller number for the number of combinations. So in your calculator here, 3,365,008.56. So a lot of different ways. And again, just don't want to say it again. There are 32 books. You pick 7, and it doesn't matter the order in which you pick them or how you hold the books or how you read the books. Just how many different combinations would you get? Nice job. So here we go. Here's another example. This one's good because of what you're going to see here in a second. But reading through and knowing what to pick. So here you're at a local movie rental store, which I don't think even exists anymore. But thanks to Netflix. But there used to be these movie rental stores. You can go in, and they have a special on new releases. So you've got 12 comedies that are new releases, 8 action, 7 drama, 5 suspense, and 9 family movies. And so you want exactly 2 comedies and 2 family movies. And so it says, how many different combinations can you rent? So here, realize, and that's going to be a tricky thing for you to realize, hey, they're actually asking me 2 separate problems. Like I could write a word problem that says, hey, you have 12 comedies to pick from, and you pick 2. And you should say, oh, that's 12C, C2. And then there's that whole nother problem going on, which is, hey, you've got 9 family movies, and you're going to pick 3. And the big deal here is to know that you're multiplying those number of choices, right? So here, if you choose the number of, I don't know if I have that, 66 different ways that you can pick to pick 2 comedies out of 12, and there are 84 ways to pick 3 comedies out of 9. And so that feels back. Yes, no, that's good. I'll take it back. And so we're going to multiply these 2 numbers together. And again, big deal that you're multiplying. You can see that in a second you're going to add them. But here you should get a final answer of 5 5,544 ways that you can pick 2 different comedies out of 12 and 3 different family movies out of 9. So again, really think of those as 2 separate problems and then take the 2 results and add them together. And so the next question is, this one gets, this at most should be underlined. So you can afford at most 2 movies. How many movie combinations can you rent? Whew. So what happens here is, there are 4, you have to tally up, and so you add up all the possible movies, right? So because there are 41 movies to choose from, realize that you're, how do I put it? If you can afford at most 2 movies, you could choose to go in the movie theater or movie store and choose none, right? So that's this first one. That's kind of weird, but that is a choice. I could pick no movie. Then you've also got 41 to pick from, and you could only pick one. You just decide, you know what, I don't feel like watching 2 movies. I'm going to pick 1 movie. And then finally, you've got the case where you pick 2 out of 41. So this is, these guys scare me. I mean, to remember this. And again, this at most 2 also includes just 1 movie, and it also includes, I don't want to watch a movie at all. And that's 1 way, right? Plus, how many ways can you pick 1 out of 41? 41 ways. And how many ways can you pick 2 out of 41 possible ways? And that's 820. And we add these possible scenarios. Again, this you multiply because you're doing this and that. And these, or you add them. So you could come out like, that's all I want to do. Or you could do this, or you could do that. And we add these up. And you get 862. So if you want to maybe try 1 on the calculator if you don't mind. Just find that calculator button. But I would definitely try this example, right? So find the number of possible movie combination if you choose 2 action movies and 2 drama. And here come your answers. So on the calculator, hopefully you were able to find the C button. It's not hard at all. 7, then go to math, go over to probability, pick C, and the NCP button, and then hit 4. And so here for the second one, you should have come up with and said there are 8 possible action movies. I'm picking 2, and I'm going to multiply because I'm going to do one of I'm going to do the first combination, and then I'm going to do the second one. So I'm going to multiply 7C2. And that in your calculator, you should be able to write this 1 line. Definitely use the multiplication, or you can do it in 2 steps as well if you want. So next one, a popular magazine has 11 articles. You want to read at least 2 articles. How many different combinations of articles can you read? Whew. Well, so what happens here is we say, well, because of the fact that you want to read at least 2 articles, you want to take away the times where you don't read any articles or you only read 1 article. So how many ways could you pick to read 11 articles? So you kind of sit here and say, well, 11 spaces. And so the first article you come up to, how many choices are there? Well, you could either read it or not read it. That's 2 choices. Next article, you could read it or not read it. That's the next one. You could read it or not read it. Again, 2 choices. So basically, of the 11 articles, there are 2 raised to the power 11. Again, I didn't carry this out because I apologize. There's just, I should have written 2 11 times because every time I come up to an article, I have a choice between reading it or not reading it. But that is 2 to the power 11. I hope you agree with that. And that's what goes here, right? So for each of the 11 articles, you can choose to read or not read the article. So you get to choose between yes and no, or read or not read, and you get to do that 11 times. So what you want to do is you want to take away the cases, where you're not reading. So this is 0 and 1, right? And so what you do is you say, okay, if I could read all 11 articles, right? That could be the case where I say read, 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 read. Then subtract away the case where I don't read. So I would pick 0 from 11. And then also subtract away the case where I read only 1. And then you should, what's the next case? When you read 2, oh, that's part of at least 2 includes 2. And then pick the case where you read 3 articles. Well, that's definitely part of at least 2. This has got to be one of the hardest concepts that we deal with this chapter. So really, I hope I explained it well. And it's a big deal. You really need to know how to do it. This ends up coming out to 2048. And then in the calculator, I would put 11C0, which always, by the way, comes out to 1. Anytime the second one comes out to 1. And also notice that this will always come out when you 11C1. This 1 will always give you the answer of the first number. But use your calculator, no big deal. And you get 2036 for a final answer. Try to set up the next one, this guy, on your own. So again, really a tricky one. The wording "at least" kind of triggers you, right? So you've got 10 football games to go to. You get to choose, right? So you have 10 times you get to choose. Do I go? And again, pretend like I've got 10 dashes. So the first time, do you want to go to the game? Yes or no? Hey, you had 2 choices. You get to do that 10 times. So the most, is 2 to the power 10. But then you need to subtract away the case where, right, if I want to attend at least 4 games, take away, 3 games that you go to, 2 games that you go to, 1 game that you go to, or no games. See if you can get it. There's the final answer. So again, going back to, you should have written 2 to the power 10. That's I choose to go to all the games, and then take away where I don't go to any games. I'm not going to any. Then I would, that was 10, sorry, 10. And then also, hey, pick where you only decide to go to 1 game. And also include where you decide to go to 2 games. And also include where you're going to go to 3 games, right? And then I think you've got it, because then it goes to 4 games, but that's part of at least 4 games includes 4 games. So realize, like, this is kind of a backwards way of, I could, if you refuse to do this method, you could do 10C4 plus 10C5 plus 10C6 ... all the way to 10C10. So again, you choose, but I think it's faster to take away what you don't want to include. I don't know if you agree, but that's kind of the scenario. And so here is Pascal's triangle. So Pascal's triangle is really down here. This is 1, 1. There's this pattern where basically these 2 numbers add to get the next number. So notice 1 and 2 get you 3. Here's the next line. Ready? 1, 4, 6, 4, 1. We do another one? 1, 5, 10, 10, 5, 1. Let's keep going. 1, 6, 15, 20, 15. You feel the pattern? It's pretty neat, and you could do this forever. 1, 7. I bet somebody did. I bet somebody's still doing it right now. 35, 35, 21, 7. And again, before calculators, somebody said, well, this is remarkable, that it lines up with combinations. So 0C0, and again, you guys, seriously, you should be like, what? This is so lame. Who cares? I've got a calculator. I can do, like here, this is row 0, 1, 2, 3, 4, 5, 6, 7. So if I said to you, hey, 7C3, I would say, okay, this is 7C0, 7C1, 7C2, 7C3. Oh, that's equal to 35. And again, you should sit back and say, well, the calculator could do it. I could have done it in the formula, 7 factorial over 4 factorial times 3 factorial. But again, somebody was like, that is really nifty that this Pascal's triangle matches up with the combinations. And hopefully you agree that's pretty nifty. So here we go. And again, I understand you have a calculator, so it's not as exciting. But the binomial theorem, which we'll do next after break, hopefully you'll be a little bit more turned on by it. Out of 5 finalists, your class must choose 3 representatives. use Pascal's triangle to find the number of combinations. So this would be 5C3. Again, the order, class representatives, there's no president, vice president.